Okay, course 121 has us doing the order of operations. But first of all, a property called the distributive property. I'd say top 12 most important things you're going to learn this year. Really key in today on what this property is telling you. It might not seem as important with just numbers. It's going to seem like a waste of time, but it becomes very valuable when you get into those letters. So 2 times 3 plus 5, according to the order of operations, you would start by adding these, right? And 3 plus 5 is 8. So 2 times 8 is 16. Fair? Okay. Now, I want to show that you could actually multiply before the adding. I know, before the grouping symbol is taken care of. That is something we need to be able to do just in case we wouldn't be able to add these. I know. Sometimes that's something that you have to be aware of. So 2 times 3 is 6, and 2 times 5 is what? 10. Then you take those products and you add them to get 16. Got it? So with like letters now or variables, I could add these, which is 2b, or not to be, and then times it to get 6b. Or I could do 3 times 1, 3 times 1, and I get 6b again by multiplying first, adding at the end. A times B is AB. A times C is AC. Can I go any further? No. Those are not like terms, so you cannot combine them. Alright, let's take a look more at the book. So you guys show those arrows whenever you do distributive property. Distributive property might not be a bad thing to put into your cheat sheet. When we use it, we can expand and then we can factor. Right? So when we use the distributive property, what we're really doing, we're expanding this to look like this. Sometimes we factor out of that, take the 2 which they have in common, and you're back to the beginning. Just depends on what's needed in the problem. Today we're focusing especially on multiplying it so that there's no more parentheses. So there you see the same thing being done over and over again here. Now notice with the subtraction right here, A times B minus C means A times B minus A times C, okay? So watch out for that. How would we factor 15 plus 10? They were just talking about factoring is like the opposite of distributing. So this looks like something that's already been distributed. In fact, you could combine it further, but if you take the common factor out, that means you take 5 out, because it's the greatest common factor, and then we need to put something here and put something here, so that if we were to distribute it again, it would go back to before. Because remember, factoring is like the opposite of expanding, which is the distributive property we just reviewed. So 5 times what is 15? 5 times what is 10? This is the answer. This is a factored version of this. Didn't see that we were going to be factoring 2 today, but this is very good practice for us. So if we expand this, we use the distributive property and go 3 times W plus 3 times M. Fair? Can't go any further because it's an M and it's at a W. So that's the answer here. But when we factor, it's like we go backwards. It's like I'm taking the 3, putting it back the way it was. So now you want to make this look more like this, where you add a parenthesis. And since there's only 2 terms, and they're both plus, I'm going to do a parenthesis and I'm going to make 2 spaces with a plus sign in the middle, and then something's going to go out here. Whatever is in common, whatever its greatest common factor is on the outside, and that's going to be A. A times what is AX? Goes here. a times what equals y here. Sorry, a times what equals ay goes here. So I did this wrong. I should have just the x. Just the y. I started going on autopilot there for a little bit. So it looks like that. We just factored there. Okay. Expand 3x plus 2. We distribute 3x plus 6. Factor this. What's the greatest common factor of 6x and 9? What goes into both? And it's the most, the biggest factor that goes into most. 3, I think, would be the greatest common factor. And then we have two terms being added. What times 3 is our first term? 2x. What times 3 is 9? 3. Now, why did I say what times 3 equals 9? Now you can check if you did your work right. What if I distributed this? What if I expanded it? It would be 6x, good so far, plus 9, which was the other term there. So it looks like where we started, it's basically the inside-out version of expanding. Order of operations, or PEMDAS, remember, parentheses, watch for exponents, multiply, divide in order from left to right. It might be divide first, then add, subtract left to right. Again, could be subtract first. Sometimes we use the old mnemonic device. Please excuse my dear Aunt Sally. So there is only one answer to this, but if you solved the whole thing strictly left to right, you would get a different answer. Notice the justification beautifully written over here. Where do I start? PEMDAS says here. So they make that 9, right? Sorry. PEMDAS says here, excuse me, make that 15. Excuse me. Then go here, which is 9. Then multiply, divide, left to right. Looks like there's multiply here with a -2. So -2 times 9 is 18. And you've got your 15 divided by 5 is 3. Then we add, subtract left to right, and 5 is your answer, but you could get something else if you didn't follow this order of operations. Ooh. Okay. Brackets look like this. Braces have these little dimples in the middle. We use them to enclose parentheses brackets, right? If you have something, if you have parentheses and you need to group the parentheses, next level up is bracket. If those need to go into something Russian nesting doll style, then you put that into braces. Brace is the biggest, bracket's the next biggest, and parenthesis is the smallest grouping symbol, if you want to think of it that way. So we start from the inside out. 5 minus 3 is 2. Minus 6 is -8. Or sorry, I was just thinking about that. That's not what it says. It says 6 minus 2 then, right? This is 2, and this is 6. So 6 minus 2 is 4. 8 minus 6 is, no, 8 minus 4 is 4. 10 minus 4 is 6. They show it blown out here. Maybe a little bit better in your book. Other grouping symbols we include are the absolute value sign, square root sign, fraction bar, meaning I don't divide here before I add. I do the top as a group, the bottom as a group. It's almost as if they're parentheses. Grouping symbols, it should really be GEMDAS, but that just sounds weird. So notice how they solve that division in example 5. They first combine the top, then combine the bottom, Then they divide according to the fraction bar. Notice this can only be solved one way. Multiply, divide first, so 3 times 3 is 9. Negative 3 divided by 3 is minus 1. And then you've got this 3 right here. Ooh, I got something wrong. 3 times 3 is 9. 3 divided by 3 is 1. Oh yeah, I got it right. Because 3 plus 9 is 12. Minus 1 is 11. I was looking at letter B, which says place a pair of parentheses. To make it 3, you'd have to put the parentheses here. That's kind of fun. They're missing a space here, though. That bothers me. Okay. Let's see. How prepared are we to do these? Let's do A, C, G, M, please.